Hello and welcome back to the Towards Data Science podcast. Now, we'll be talking a lot about the data science lifecycle today. And if you're a Towards Data Science reader, you'll know that we've had some really interesting articles on that topic as well. So this actually seems like a really good place to remind everyone that if you have an idea for an article on that or any other interesting data science topic, don't let it sit in your drafts folder. Fire it away, because I know a bunch of editors at Towards Data Science who would love to check that out. So on to today's episode, which is going to be really interesting because it's rare that we get to spend an entire episode talking about just data. So let's say that you're a big hedge fund and you want to go out and buy yourself some data, right? Data is really valuable to you. It's literally going to shape your investment decisions and determine your outcomes. So you go out, you buy your data, and then a cold chill runs down your spine. How do you know that your data supplier gave you the data they said they would? Right? From your perspective, you're just staring down 100,000 rows in a spreadsheet with no way to tell if half of them are made up, or maybe even more for that matter. And this might seem like an obvious problem in hindsight, but it's one most of us haven't even thought of. We tend to assume that data is data, and 100,000 rows in a spreadsheet is 100,000 legitimate samples. Now, the challenge of making sure that you're dealing with high quality data, or at least that you have the data you think you do, is called data observability. And it's surprisingly difficult to solve for at scale. In fact, there are now entire companies that specialize in exactly that. One of those companies is called Zectonal, and their founder, David Hirko, will be joining us for today's episode of the podcast. Now, Dave spent his entire career studying data observability, the challenge of evaluating and understanding data at massive scale. And he did that first at AWS in the early days of cloud computing, and now through Zectonal, where he's working on strategies to allow companies to detect issues with their data, whether they're caused by intentional data poisoning or unintentional data quality problems. Dave joined me to talk about data observability, data as a new vector for cyber attacks, and the future of enterprise data management on this episode of the Towards Data Science podcast. The topic for the day is a little bit offbeat because we normally talk about algorithms, scaled AI, alignment, safety, those sorts of things. I think the story that we'll be exploring today is not entirely untold, but it is less explored, and it's no less important. I mean, we're really talking about data here, the kind of foundation on which all our models are built, and you've had a really fascinating journey in this whole space, in the space of what's now become known as data observability. I'd love to understand so first off, what brought you here? What brought you to this world? And then maybe give listeners a bit of a sense of what is data observability as well?
Well, I think the journey to where we are today really starts with my time, early days at Amazon Web Services, at AWS, and kind of in the early days of cloud computing, where we just saw the massive amounts of data that were being stored and collected. And as those storage costs started to go down and the ubiquitous kind of ability to have access to massive amounts of compute for really low costs, everything started with a data-centric world in my mind. When joining AWS. Having been there for several years, I always like to say AWS is the second best company I've worked for. Just a phenomenal experience. We decided to start our own company in about 2014 that was really focused on distributed analytics. So if you think about those early days of Hadoop and Spark, it was really, folks didn't really think that you could run those kind of distributed systems in the cloud outside of AWS. A lot of the companies, like Cloudera, Hortonworks, were really kind of pushing more of an on-premise view. And so we started a company to really focus on that. And then we were involved in a lot of the alternative data, fintech space, where we're starting to see these really esoteric data sets that were being used by financial institutions, hedge funds, and the like. And that was really kind of the first inkling of how do we start monitoring data? How does the data that's feeding these algorithms, how should we be treating that? And so I had an opportunity after about 8 years of starting my last company to kind of start this new venture that we call Zectonal. And that was in February of 2021. And we were really focused on data observability. We weren't using the term at the time. I think it's a fairly new term that's kind of taken root over the past couple of months. But the concepts are kind of similar. How do we look at trends in data that feed algorithms? I wrote TensorFlow algorithms for several years, and you start to really see that a lot of the errors that are introduced into specifically training for machine learning algorithms come from abnormalities inside the data itself. It's not always the algorithm. You start to measure the performance of an algorithm. You start to say, well, where are the discrepancies coming from on inference? And almost always it was coming from the data. So, like all folks, like we started writing code and in February 2021, and here we are today with, our product that does data observability. And the final note on that is, having come from a little bit of a cybersecurity background, I was fortunate enough to have started Apache Metron, which then kind of incubated all the way through to a top level Apache project. We felt like that security just needed to be embedded in data observability. And so looking at kind of not only the characteristics of data quality, but are there threats inside of the data? And I know we'll talk a little bit more about that later, but that's kind of how we got here.
Right, and actually, I mean, that's such a great teaser for the massive iceberg we're about to unpack here with data security being connected with data observability. It's something that took me by surprise, actually, even though I was tangentially aware of some of the security issues, that you can run into here and there. When I read some of the posts that you put together on the topic, like, wow, holy crap, like there's a lot here. So before we dive into that, though, I do want to unpack this term data observability maybe a little bit more, looking at, in particular, like what are some of the metrics, some of the ways that you judge data quality when you're looking at obviously data observability, right? It's somehow tied to the assessment of data quality. Is actually that's a good question. Like, is data observability almost like the verb, the action, and then data quality is like the noun, the target of that action, or how are those related?
I that's how we would define it. I mean, our customers define it really historically as like data characterization. And you think about the macro and micro trends in kind of how you acquire and ingest data. And so for a long time, we just called it data characterization. I think the industry has taken hold of the term data observability. Certainly it helps when you're defining markets and things like they go into Gartner Magic Quadrants, but I think it's really kind of looking at macro and micro trends and how you acquire data. So, some of the key metrics, and we started to look at this early on, kind of from my background, service level agreements with data providers. Are you getting your data on time? Do you have an SLA for data arrival? If you're a Wall Street trader building, super fast algorithmic kind of trading platforms, like you want to make sure your data is getting there on time. And
Right.
oftentimes you don't want to be trading when your data doesn't come in. So sometimes something is just as easy as do you have a green light or red light? Is your data coming in? And so we kind of started with that basic concept. And then you get into some kind of more higher level kind of data quality characteristics, like is your data stale? Not only did your data not come in, but is your data late? So we'd see oftentimes where, especially for like machine learning training, if your data came in a week late because your upstream data provider somehow didn't get an ETL job done when you thought it was going to get done, and all of a sudden you've got this model that's doing inference, what you believe is on real world kind of scenarios, and then you get this whole bundle of data a week late, what do you do? Like, at least you want to know
Yeah.
that the algorithm should be retrained, or maybe it shouldn't. But you want to have an indication that maybe it's not necessarily complete. And then from there, our customers make decisions whether to retrain or not. Sometimes it's file size, file volume. A lot of times we'll see just basic things like, are you expecting 10,000 files a day? Did you get 10 less? You look at aggregate size per day, aggregate size per month, especially if you're buying data from the commercial market. When you look at like ad tech data sets, when you look at
Right.
geolocation data sets, those are very, very expensive data sets for a lot of consumers. And so you want to know, like, am I getting everything that I bought? And, it's beyond the ability for humans to kind of look at that and understand it. And so you really need tools and capabilities to kind of look at that. And so those are some of kind of like our macro kind of quality concepts. And then we think about some of the more micro concepts. And so starting to peel back and look inside the data and starting to see, like, am I getting all the right columns as part of this schema? You'd be probably not surprised, but it's surprising to me, at least, if you think about like tab separated files, CSV files, the amount of times that you may have like an unencapsulated comma that then creates an extra column at the
Yeah.
end that throws out of whack some kind of downstream analytic system. And so again, at certain scale, you want to be able to detect those things. We see patterns where null values start to get introduced into very large data sets, and you want to start to quantify to say, if my baseline is that 25% of the data in a Parquet or a CSV file is null, but that starts to climb up to 50% null, that's an indication that something's amiss. And of course, those all have significant downstream impacts on algorithms that use the data. So we think of like data observability as both kind of the macro and then the micro kind of trends that are going on.
And I imagine, if listeners who are thinking about this through the lens of some of the episodes we've done on safety, like this also starts to become relevant too. You start to talk about, in one case, you mentioned data that comes in late. Well, we have a word for that in AI safety. It's called out of distribution potentially, or you could be looking at a problem like that. So making sure your data is on time is actually a safety problem in many cases. It's really fascinating. I'm curious what some of the sort of, let's say, funny business that you've seen happen with data providers, because I did read about this a little bit. I found it almost slightly amusing, but it is also concerning. What are some of the things that your customers, your clients have discovered when they've turned these sorts of observability tools on, especially with respect to third-party data suppliers?
Sure. I mean, probably the funniest story I've ever heard. And, it was a fairly significant financial services institution, and they were running their data pipeline using a bunch of Python scripts that was running on somebody's laptop. And so we were looking at kind of the trend of when that data stopped flowing as part of our own kind of product and time series. And then we started to correlate to, well, the data stopped flowing every time that one data scientist closed their laptop lid,
Oh my
right? And
God.
so then the pipeline kind of shut down. So, you think about non-resilient data pipelines that are feeding kind of these, very, expensive, revenue generating algorithms, and there's something simple and silly like that. So, it was funny in hindsight. I think, at the time we were just like, let's think about how to build a more reliable data pipeline here. But there's all sorts of things, people. I mean, it really just turns a light bulb on an area of focus that just a lot of organizations just aren't looking at. I mean, I think we're in an era where everyone understands that their data can be monetized. And so, compared to 5 years ago, where you have to convince people to save their data and store it in low cost, now we're really kind of evangelizing, like, are you aware of the quality of the data?
Right.
If you asked a lot of CIOs and big enterprises, how much data are you storing? I think you may not always get the accurate answers. In fact, we're finding that a lot more CISOs have a better appreciation for their data assets than maybe even the CIOs. But the world's changing, where people are wanting to quantify now, what is my data worth? Not only am I storing it, and I think we play a part in it.
Yeah, I mean, and what a big problem to take on as well at this point. And to do that, actually, one metaphor, one analogy that you've started to lean on, I've noticed, is this idea of the data supply chain. Would you mind unpacking that a little bit? Like, what is a data supply chain in your eyes?
So I'll use the example of weather data, because I think weather data, surprisingly, is used by so many organizations. And so if you think about fusing weather data into other type analytics, if you look at earning statements from like CEOs, a lot of times they'll blame bad earnings on like bad weather patterns, unforeseen weather patterns. And so how do you bake that into kind of your algorithms? So weather data is typically bought by a data aggregator, but it's federated through many layers of a supply chain down to probably an individual piece of hardware that you could put outside in your backyard or put into a park. So there's literally tens or hundreds of thousands of these devices spread out all over the world, and they all kind of generate this data that gets aggregated, usually through multiple different companies. And what is really shocking to us is we'll go into a client and we'll say, well, who are you buying your weather data from? And there's a couple big name weather data providers. And then we'll say, well, do you know where they're getting their data from? Because they're then buying their data from different aggregators and buyers. And so it goes all the way down. And so trying to track where is the actual source of your data coming from, down to that individual sensor. And if you think about traditional supply chains, and one that you study because of history, is like, you think about automotive supply chains. Some of the big car manufacturers, I mean, they know where every nut and bolt and screw comes from in their providers.
Yeah.
And what's so surprising is our algorithms and many of our training algorithms and analytic insights come from data that we really have no idea, one step removed, where it comes from. We may be buying from a provider, but we never really ask where that provider's buying from or where that downstream provider's buying from. And so for us, that's really the idea of like the data supply chain, and it's a global data supply chain. And it
And do you
has,
think of
yeah.
Oh, sorry. No, I was just curious. Like, do you think of the data supply chain as including not just like where the data comes from, but then like the other steps in kind of the data processing, the data lifecycle, essentially? That's all to you. That's part of that supply chain.
It is. It's, I mean, data lineage. How do you know that people aren't changing concepts slightly? You know, whether it's the name of a header inside of a schema or a column, or introducing some kind of errors. I mean, the way that we started thinking about data security was because there were just errors being introduced unintentionally as
Right.
part of that supply chain. I think the CEO of NVIDIA always talks about data factories. And each one of these aggregators is a data factory. They're taking in inputs and they're creating outputs. And there's going to be anomalies, there's going to be errors that are going to be introduced in that processing. And you carry those errors forward, you carry those quality issues
Yeah.
forward all the way upstream to where the final product is being made. And that final product is it's a model, it's an inferencing algorithm, it's a BI analytic. And the ability to try to detect those early is really important.
And I guess just like a regular supply chain, bottlenecks show up in really weird and unexpected places. I mean, you just gave the story of this one engineer who's opening and closing his laptop, causing an entire downstream effect to unfold. Not entirely unlike any number like TSMC in the semiconductor supply chain, or Ever Given, that big cruise ship that bottles up the Suez, and then all of a sudden our goods are 10 times more expensive or whatever. Like it seems very apt, like this connection, as well as from a national security standpoint. Increasingly we're starting to look at our supply chains as a source of national security risk. Where are people inserting? Maybe where is China inserting stuff into our hardware or whatever else? I'm curious about that aspect. Like, what are some of the those security implications then that you see the moment you start looking at data through a supply chain lens?
Yeah, we don't know. I mean, we're not that involved in the national security component of it,
Oh,
but sure,
sorry.
but
I meant
sure.
the
Yeah.
cybersecurity aspect. Yeah.
Yeah, but sure. I mean, I'm sure it exists. I would say too, like, I think what's really interesting too is just the compliance perspective. I mean, you think about all these kind of data sovereignty. You mentioned, China, and I mean, the data sovereignty laws there seem to be changing fairly quickly. You look at Europe and some of the data. So I
Hmm.
think if you're an enterprise consuming data, again, you carry forward some of those data supply chain kind of liabilities, if you will, if they do exist, or even wanting to know if they exist. So I think visibility into your data supply chain is key, and I think more and more organizations are going to have to start looking at that, and then putting a price on high quality versus low quality. I mean, it's very difficult. I mean, we think of data observability is a way to kind of put a price on commercial data. And
Hmm.
is it good data, is it bad data? Sometimes you just want cheap bad data to kind of feed a learning algorithm where you just need a lot of scale, and other times you may want to buy more expensive lower volume data just because you'll get better outcome on that. So
And on the cybersecurity side, I mean, I know there's a really big story here, and you guys have done a fascinating study on this like log4shell vulnerability that we'll get into in just a minute. But I'm curious about the role that data poisoning plays in this picture. Can you unpack that a little bit? And what are some of maybe the stories you've encountered when it comes to data poisoning?
yeah, and I have been in the cybersecurity field, but I'd say like there are a lot more folks who are more intelligent about this than I am. So I'm going to use a term though that is often used kind of in the cybersecurity world called fuzzing. And fuzzing is when you unintentionally throw a lot of data at a particular software application and see kind of what unintended side effects result from it. And it's a way then that when you fuzz a system that you're able to kind of figure out like how does it behave abnormally. And for us, our kind of fuzzing experience was really just watching these data pipelines over years collectively from different vantage points in different industries. And you'd see things break. You'd say, well, why did that Kafka node go down in the cluster? Why did that Spark node go down in the cluster? Like, why did Elasticsearch not do something that it was supposed to do? And then when you do kind of a deep dive post-mortem, you start to see that it was probably an unintentional malformed piece of text inside a Parquet or a CSV file. And you say, well, geez, like if that caused that, what would happen if somebody deliberately did something like that? And I
Right.
think, that kind of unintentional fuzzing of these systems using these classic kind of data transport file codecs like Parquet, Avro, CSV, TSV. I mean, that was kind of how we learned a lot about how these kind of vulnerabilities may exist. And it's a big part of our data security story. It's not necessarily that we saw intentional, um, packaging of malicious payloads, but sometimes they're just unintentional. We talked about the data factory. It just could be a manufacturing glitch on an ETL job that created like a partially completed file or text string in a CSV that just caused the system to go down.
And how do you detect that when it happens? I mean, that seems like such a daunting challenge. Just there, there's an issue in the data somewhere. It's anomaly detection, I guess, or something like that. Like what's
So we have this term that we call deep data inspection, and it's kind of borrowed as an analogy from like network packet inspection. So if you think about 20 years ago, when folks were thinking about securing networks, there was a lot of encrypting data that goes across the internet. And so people started to look at the actual contents of network packets, and they started to look inside of them. And it was kind of this industry was born for forensic network analysis.
So can I ask a really stupid question? What is a network packet? Like, what exactly should I be picturing?
It's, if you think about routers and switches that get connected to, wireless networks, it's the most primitive piece of data that gets pushed on to the network.
Okay.
So it will contain some information about, data, right? So it could be email, it could be web traffic. It's just a fundamental kind of data transport kind of building block. So we use that analogy with deep data inspection. So if there's deep packet inspection, then we started to say, well, let's start looking inside the data itself. So, a CSV file, a Parquet file, we can query the contents of that file. And so we started to develop software to do that. Oftentimes, these files will contain, tens of thousands of individual data points. I mean, for some of our listeners who may not be familiar with a Parquet or a CSV file, I mean, we always say, think of it as like an Excel spreadsheet that's like, 10,000 rows by 10,000 rows. I mean, and all you need is a single cell inside of that spreadsheet to contain some kind of malicious payload to trigger some kind of vulnerability. And so we look inside that, and we look inside and say, is there something that looks anomalous in here against some patterns that maybe we've seen in the past, or some of what we think may be occurring kind of research wise. And so that's what we kind of refer to as deep data inspection.
Okay, and I think that brings us quite smoothly to this like log4 shell vulnerability that you've explored recently. Can you tell that story a little bit? Because I think it does a great job of illustrating the stakes potentially of this sort of inspection.
So, the Log4j shell came out last December. It was a really big deal. I think every organization very quickly, I think the government said it was like a 10 out of 10 in terms of just the ability for it to be exploited and the simplicity of the exploit. So the first thing that we did, obviously, just like every other kind of business, is we looked at a lot of the systems that we were using at the time. And of course, a lot of these kind of distributed processing systems are heavily reliant on Java and a lot of the Java libraries. And so we happen to see that, I won't name it here, but, a fairly large open source distributed processing application was vulnerable. And everyone patched it fairly quickly. I mean, I think there was a great industry-wide effort to patch Log4j, but as kind of you and probably our listeners know, oftentimes these systems just go unpatched for long periods of time. And so, we saw Log4j, and we saw kind of how it was being documented to exploit systems. And we just took a different perspective on it. And we said, well, what would happen if the same kind of vulnerability were packaged in some of these kind of file formats that we see, every day, that every enterprise is working on? And knowing that, one of the systems was vulnerable, we happened to run it through that kind of ETL process. And next thing we know, we were taking, remote access control of that node in the cluster from deep inside, a private virtual private cloud. And so we were just like shocked. And like I said, like, it was one cell amongst probably 10,000 different data points. So it was like really tricky to find. And we were just like, wow, like this is data poisoning. And
how does that contrast too, sorry, with like how the standard approach would be to like exploiting the log4j vulnerability? Like what would be a more standard vector of attack besides the data?
I'm not an expert in this, but my understanding was that you'd have these kind of internet facing web servers that had the vulnerable logging library. And if you kind of sent um, kind of a malformed packet string with the user agent was, a particular string formatted in a very specific way, that would allow you then to take over kind of that internet facing web server, which in a lot of ways it was, the web server was kind of exposed to the internet anyway.
Right.
If you had kind of the proper defense in depth architecture, I'd assume that even if your front end web server was compromised, hopefully that still wasn't like, access to kind of the crown jewels of the enterprise. And so, while that was kind of well documented, that particular attack vector, I mean, the one that we found was, you know, exploiting a system that was well inside of, probably most defensive perimeters from a cybersecurity perspective,
Right.
and took a path that, sometimes, I don't know how frequent, but didn't always scan these kind of files. There weren't traditional kind of application firewalls that would be scanning this kind of traffic. So, we thought it was a little bit unique. And again, it was something that we published and made everyone aware of. It was already a patch system, but in our world, it was like, here's unfortunately the future, right? So, we always tell people, if you're a data scientist with a Jupyter notebook and you use pandas, like, be careful if you're downloading that file from the internet to do some exploratory data science, because, as far as we know, like, how do you know that
Right.
pandas just wouldn't get exploited as soon as you open that file and parse it, or a matplotlib library? I mean, you have to be a little bit paranoid to live in this world to think like that. But, uh, unfortunately, I think that's kind of where things are heading.
Yeah, it's incredible how the attack surface area just keeps growing and growing. It seems like, what you've just described as the initial attempt to exploit the vulnerability, it sounds more like a full frontal assault on an API. And it's just like, okay, let's go after it. But when you start to play this kind of Trojan horse game, and get in through the data to the, also, I mean, a lot of data gets stored, not client side, but like deep, like you say, deep server side, like really behind all those security barriers. And it's like, what that could do, is it's scary to think of. I'm curious in that sense, like, how have you seen things evolve over the last, say, I don't know, the last 10 years maybe, as you've been involved in this space? Like, have you seen the complexity and sophistication of these sorts of vulnerabilities increase? Like, what's the direction of change that you've seen?
Well, I think just in the cybersecurity, market in general, I mean, people are becoming more aware of it, and it's evolving faster because the repercussions of, you think about all these data breaches that have occurred and the visibility they've had on those organizations, and the revenue impact. And so I think people are a lot more aware of it, and probably, like, similar to a cat and mouse game. I think the people who are developing these really nefarious kind of vulnerabilities and exploits are having to evolve and get more sophisticated. We use exclusively a programming language called Rust, which, is inherently secure, is very fast. And, we're starting to see, more and more malware just this year that's being written in a performant kind of, secure programming language, which I think makes it harder for folks who are trying to defend against those kind of things. So I think it's just upping the stakes. And again, when you think about data lakes, data warehouses, lake data lake houses, delta lakes, I mean, all those, like, there really hasn't been an emphasis around security with those. And so you think about people that are using that data to kind of inform analytics, and the systems that do it are traditionally not ones that you secure. You're
Right.
thinking about securing the outer perimeter, but like you said, a lot of these ETL analytic, uh, machine learning kind of, internal kind of systems, these distributed systems, aren't traditionally ones that people think a lot about securing.
And I think you wrote about this too, this idea that you usually just discover these issues at the very end of the process. Once your model fails, there's like an obvious external manifestation. It's usually at the very end of all that process. Is that, are there steps people can take to kind of catch things earlier? Like, what would you recommend to? Well, let's start maybe with the enterprise level, because that's, what you're focused on most right now. But
Yeah, like I mentioned before, I like that term called fuzzing, which is where you just pay attention when things crash. And, I think, I'm a product of AWS, where, you do very deep postmortem on outages and any kind of incidents. And I think for any enterprise, like if you see an ETL job fail, if you see an analytic that you're somehow able to kind of understand is not being accurate, I mean, do a deep dive. I mean, over time, you'll start to see these patterns. You'll start to put together like, this is what caused it to fail. And, if it turns out a certain way or is formed in a certain way under certain circumstances, and just document and retain that knowledge. I mean, that's how we got started. We just started to build that knowledge base from seeing how things fail, and then trying to document and not just fix it, but really try to truly understand like what was the real cause of that failure. So that would be, the best advice I'd give to folks. Just pay attention to it.
And I guess again, the vast majority, at least for now, the vast majority of these things are accidental, are not kind of these intentional failures. So hopefully there's, I don't know, a little bit more statistical regularity in terms of what those failure modes look like. Is that fair to say?
It is, yeah. To be very candid, like we have not seen at this point in time like a malicious data
Right.
poison attack in the wild. I think there's a lot of conjecture about it, and we documented and published our research about one particular way to do it, but we certainly have not seen it. Now, that being said, a lot of people who spend a lot more time in the cybersecurity industry than I do, that we've talked to and briefed, I mean, they said like this is probably the future. It's not necessarily
Yeah.
what's keeping them up at night today, but 5 years from now, I think this is going to be a series of threats that I think everyone's going to have to deal with.
And I guess it's also like you're always climbing down that ladder of sophistication in terms of these attacks where the average person, even the average organized crime syndicate, isn't going to be using the cutting edge stuff. But nation state actors, things like that, maybe at first are using it, and then gradually as tools become more and more available, the attack surface area increases and there are more and more people exploiting these sorts of vulnerabilities too.
I suspect that would be the case as well. Yeah, I'm every enterprise deals and has these type of systems. I mean, it's happening all over and all the time. Not that people are being compromised, but these outages are happening and these malformed kind of files are being processed, and so people are learning from it. It's not unique to anything that we're doing. I mean, it's so ubiquitous that there's going to be
Yeah.
others who are going to figure this out as well.
But then I guess there's also the challenge too of like, how do you even verify that this is or is not being used today in the wild? Because I mean, if the attack is successful, you could be introducing vulnerabilities that don't surface until much later on, but like by design. Yeah, and it's something because like we talk a fair bit about malicious uses of AI and like large language models, and there's always this question in that context about like for example, is Russia, is China, are kind of adversaries using these techniques to interfere in democratic processes? And it's like, well, if they are, if you're using a genuinely human-like system to interfere, then there's going to be very little evidence for it because it's human-like. That's almost the point. That's part of the challenge.
It totally is. I mean, you think about just subtleties and training data, if it were intentional that you could subtly change data sets that you knew would have an impact on an inferencing algorithm,
Right.
I mean, it'd be so difficult to detect. I mean, the one that we found and published, it was real obvious. Somebody took control of, a server deep inside of an enterprise. But I would suspect a more subtle, longer term would be to just, poison the data in ways that were almost, impossible to detect, knowing that the algorithm that was trained off that data would be subtly, changing kind of how it saw the world over time. And that could be really, really difficult to detect, I would suspect.
And at the more kind of individual level, because obviously a lot of our listeners build personal projects. You mentioned the pandas thing, like watch out what data you use for that. I'm sure that will have sent a cold chill through the spines of a few people. But obviously we're not talking about this being a present day massive scale concern for the average person. But are there steps that you think the average person ought to take when they think about data provenance, when they think about like what data am I going to use for my personal project or things like that? Are there things at this stage they should already be thinking about?
Not to oversimplify, but I think it's similar to, what we all experience in our email inbox probably on a daily basis, where we get spam mail, we get links, we get text messages with links. I mean, knowing what files you're going to be using, I mean, knowing that they're from a trusted source. If you're, downloading, New York City traffic data to do kind of like a example data science project, and that data is probably safe and it's hosted on, a well-known site, I think, there's some good intuition there. But if you're looking at a site that doesn't have a domain and maybe it's just an IP address or something sketchy like that, I mean, I'd say be careful, because I suspect there's a lot of bad data out there. So I think it's that same kind of hygiene that we've all gotten used to about what we open in our email boxes or what text messages we open. I think applying that same hygiene to kind of the files that we consume from the internet for data science, I think is really important. But surprisingly, like, you'd think it'd be easy because we're all so trained in that. And yet, we still don't do it. I mean,
Yeah, well, but to your point earlier, it does feel like data, for some reason, we treat psychologically as like a safe category of thing. It's like our soft underbelly. We assume that data just doesn't get used for adversarial purposes, and shockingly, like you said, it applies to enterprise as much as individuals. But maybe that's something that's going to change. You start imagining like people thinking about data the same way they think about spam email, that sort of thing. That's a pretty big shift psychologically for the whole space.
it really is. Yeah. I mean, you said it, spot on. It's just we treat it differently. I mean, we treat it how it comes into the enterprise differently. The ingest paths, the data pipelines, they're architected differently than how regular, I'd say more common type of data comes into the enterprise, and how it comes through firewalls and how we treat it. And so, you hope that it doesn't take a series of kind of, bad incidents to bring awareness to it. But it is treated differently. You're absolutely right.
And do you imagine a future then where there are, and actually maybe this speaks to the design of the Zectonal product, but like, do you imagine a future where at every stage in the data lifecycle, there's a dedicated series of checks on data for deliberate poisoning or just like kind of crappy data for whatever reason? Or is it, how do you imagine that architecture playing out in the long term?
I think that's a great question. I don't know how other folks exactly. I mean, we spend a little bit of time looking at other data observability products, and there's some great companies out there. But we've architected our products so that we try to find data quality, data security issues before they get ingested into the data lake. So we think of like that, and there's many terms, the data warehouse, data lake. I'm probably using them interchangeably, and shame on me for doing it. But if you think about that enterprise data repository, for us, once bad quality data or a vulnerability gets in there, like it's game over, right? It's too late.
Right.
Like, and so we think about architecting not necessarily like at the edge, but we think about kind of a product that will look inside data before it gets into the data lake. Because it's not enough just to be able to determine that there's bad data quality issues, but we want to prevent it from kind of upstream. So I think there are some architecture paradigms that will need to change with that. Like to your point, like where do we monitor that in the data pipeline, like in the life cycle of data? And I think it will probably, if have to be various different points. What does that data look like pre-ETL? What does it look like post-ETL? What does it look like once it is in the data repository? I think that's just a healthy way to look at it.
Interesting. And from almost a business standpoint, I'm curious because every time I see a company that's selling to enterprise at scale with all the legacy tooling that comes with that, kind of the big challenge of customization, do you find yourselves building custom solutions for enterprises? Like, is it basically a case-by-case basis? You kind of look at the whole architecture of their data supply and you go, okay, you need checks here, 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 and here? Or is it like a one-size-fits-all thing, or are you seeing at least some consistent threads?
So I grew up in the era of, SaaS business models,
Right.
Working at AWS and seeing kind of the boom in software as a service. And I think the pendulum has swung a little bit the other way. SaaS business models are great and there's many efficiencies you could drive out of it. But I think especially when it comes to enterprises data, there's still an aspect that I think needs to be kind of on premise. And I think we've built our product to be really lightweight. It's almost like a utility that you would install on a Linux system. And so having, these big Spark clusters that are looking inside the data warehouse, they just felt like that was too heavy of a lift for a lot of enterprises. And so we realized based on our experience that the best thing we could do was kind of hand our software in a really easy to way use to our clients without us having visibility or access into their data. And I think enterprises get very, finicky if they're handing kind of the keys over to third parties,
Right.
right? And you think about a lot of the threats that are coming into enterprises, they are coming through third parties. They're so we designed a product that was very lightweight, that we could get up and running in a couple minutes, couple seconds, and kind of interrogates the data from there, as opposed to like a big, heavy kind of software as a service. And I think too, like we're a post GDPR company, and so you think about those compliance regimes that now everyone, not only countries, but now even individual states within the US are, starting to impose. And so I think that's also going to benefit us how we've designed and built the product, so that we could kind of just snap right in, and there's not like this monolithic, SaaS product that exists in some Amazon region that needs to support various constituents. So we've tried to incorporate a lot of lessons learned around architecture, around data and data governance, data provenance, data liability into our product to make it as lightweight as we can.
It's really interesting to hear you kind of reference the policy landscape, the GDPR story, as almost integral to the foundation of the company, or at least the architecture of the product. And I think that's something that a lot of people might not realize, especially if they're working in a smaller scale startup, that sort of thing. Like, this is a thing that does change the way companies operate, and it's really interesting to hear like the pre and post GDPR period, and how much adjustment. Like, how hard would you say it would be for, it's impossible to say really, but like, what are some of the big challenges that are involved in moving from like a pre-GDPR era to post? Like, what are some of the things you've had to do?
We've seen other companies struggle with it in a past life. Like, we helped companies migrate to that. I mean, when GDPR was on the horizon in these organizations that were, serving international customers, and they had to quickly come up with a way to kind of create these various storage footprints. And so we learned from that. I mean, there was just a lot of engineering time and cost and resources, and um, people building different, cloud-based data repositories. And I mean, you've seen kind of the big three cloud providers now have regions and points of presence in so many different countries, and grown to kind of accommodate that. So we kind of looked at that and said, like, let's just design lightweight, drop in really quick. And it was a big influence. But I think enterprises, at least in the United States, I mean, that's where most of our experience has been. Um, it's not as much even like compliance that drove them, as much as it was just kind of safeguarding
Right.
their data. I mean, they don't want third party technology companies to know what's in their data. And we feel the same way. Like, we don't want to know what's in their data. Like, we want to give them a capability to look at quality metrics, and to feed it back to them, provide alerts when things go bad. But we really don't want to have access into our tool once it's deployed in our
Yeah, it's another
client's environment.
liability for you, actually.
It
Yeah.
really is. It totally is. And it makes it, I've been in sales, like enterprise software sales, for 20 years. I mean, it makes the sales process a little bit easier when we kind of lead with that message. So, so we designed a product that would help kind of make that more possible and easier, less friction for our customers.
Okay, well, that's great. Last question. I just want to pick your brain about the future a little bit here. What are, I mean, you've talked about some of the trends moving kind of more and more towards, well, potentially data as an attack vector, among other things, and then the interest in data observability. What are some of the things that you expect to have happen in the future? Like, do you just see this continuing, and eventually data just becomes like every kind of, like, it's almost like an API attack against the system. Like, it becomes just one of these walls that needs to be built? Or I don't know. Could you speak to that a little bit?
Yeah, I think, we're obviously, I mean, this is really a no-brainer statement. And so, sorry, but, we are so reliant on data to feed our algorithms that, we are becoming a byproduct of the data that we use in everything that we do. Our algorithms are based on it. And so, of course, it's going to be a target for folks to kind of manipulate. Um, they're probably thinking of ways of manipulating it that we couldn't even comprehend at this point in
Right.
time. Data poisoning as a topic has been out for at least 2 or 3 years, and people have been thinking about how to poison machine learning training algorithms. So I think there's just, unfortunately, like, it's just another series of threats, just like, the network was, something that needed to be secured and built over, a decade post time. So I think we're just going to be thinking about kind of how do we protect our data repositories. I think another really interesting, fascinating topic for us is the emergence of synthetic data. And, I know you've talked about this on some of your prior podcasts, but the idea that you create intentionally fake data to supplement, the training of algorithms. And we've used it ourselves. I mean, if you think about fraud detection use cases, the classic kind of imbalanced training data set, hopefully it's imbalanced. You have fewer fraud cases and not fraud cases, but you see there's real value to supplementing training data for something like that. But at the same time, as that kind of emerges, enterprises are going to start to really think about, like, do I want to store that much synthetic data? Do I want to not only pay for the cost of storing it? Should I secure synthetic data in the same way I secure real data? If I'm buying commercial data, and paying a very hefty price for it, how do I know that my data brokers, and data brokers, there's not always some great data brokers out there, aren't supplementing their data with synthetic data and just not telling us, right? And they're charging a lot extra, and you think you're getting 10,000 monthly active users, and in reality it's 5,000, but they've supplemented with synthetic data. So I think we're also going to be entering into a world where I think data observability is going to play a really big part in this, of being able to differentiate like real data from synthetic data. And I think enterprises are going to have to figure out how they treat it. It's not really for us to figure out how to treat it.
Right.
But I think it is up to us in the data observability space to be able to kind of tell our customers or give them an indication when we might be seeing synthetic data versus actual data.
And is that, I'm thinking back now to a couple of podcasts that we did, one more recent one in particular about synthetic data. And one of the themes there really was this idea that you could actually, you could enrich, you could add value to your data by using synthetic data. Essentially, just for listeners who haven't heard the episode, something like, imagine taking GPT-3 or like a large language model with all the world knowledge that it's collected, right? These models know what a clown is, what the sky is. They know all kinds of concepts. And essentially, you take your data as an input, you train the model to create new data as an output, but leveraging all that implicit knowledge that it contains, essentially creating an output that accounts for a whole bunch of facts about the world that maybe the original data didn't even consider or include. So in that context, I don't know, like I'm imagining this is going to be a massive challenge. Can you think of any, like, are there strategies? Are people even thinking about how to overcome that?
We think about it. I mean, we ask ourselves a lot of questions because we are starting to see it emerge, just like you said. And to your example, I mean, it's fascinating because the whole purpose of creating in our mind, creating a lot of these more sophisticated algorithms is to model the real world, right? And so sometimes you do need to supplement. But what happens when the real world that you're trying to model changes at a pace that's faster than the synthetic data could kind of incorporate, right? Because it's kind of building on each other. So we ask ourselves a lot, like, how can we detect and differentiate? And again, we're not saying synthetic data is bad. We've been consumers of it. We see the value, but we think it's really going to be important to differentiate what's real and what's not. And, it's going to be cost. It's going to be how fast can you pivot your algorithms and your models, just to your example. It's just another level of awareness about people's data. It's, how can I observe it, and understand that a little bit more.
Well, I've got to say, reading a lot of the material you put together on this topic, it was like the future coming at you in fast forward. Because I wasn't even aware at the time of the idea that like data providers would just be fudging the numbers, like packing the envelope with like a whole bunch of like, even just replicated data, and then we've got synthetic data on the horizon, just like in a way kind of value added. But if you don't know it's synthetic data, if you're operating under the assumption it's authentic original data, it's interesting. I mean, like we're heading almost to a world where the snake's eating its own tail. We have like AI systems that are going to be trained on top of data from other AIs, like synthetic data generated by other AI systems, and we may be doing a lot of it without even realizing it. So just a fascinating exploration. Thanks so much, Dave, for the great conversation.
Well, thank you for having me. And I really, really enjoyed these set of topics. And so thank you again for having me today.